down. Today we'll be doing the experiment on spearmint oil. And so the purpose of this lab is that we're going to use column chromatography to separate the different components of spearmint oil. And then we're going to pair that with the technique we learned last week, the TLC, to identify what those components are. So I'll talk more about what column chromatography is in a second, but the major importance from this lab is that essential oils, such as spearmint, are very popular now. They're used in things, a lot of dental care, bubblegum, stuff like that. And so as they become more popular, people are looking for cheaper ways to make them. And unfortunately, that usually involves adulterating them with things that aren't pure spearmint oil components. So the pure spearmint oil components are right here. And those are R-carbone, which is 73%, R-limonene, which is 8%, and then 1R, 2R, 4R, dihydroxycarbiol, and that is the remainder of it. So we are going to use, as I said, column chromatography to separate out these three components and then compare them to known samples to see if they are at all adulterated or if they are pure. And so to do that, as I said, we'll be using column chromatography. And so column chromatography, it pairs very well with TLC. Whenever you do a column, you're generally going to do a TLC as well, if you do any type of organic research. So it is also based on polarity, where the non-polar compounds will come off first, they will loop first, and then the polar compounds will come off second. So as you increase the polarity of the solvent, you decrease the binding of the polar molecules to the silica gel, which is polar, and that releases them from the gel, and that's how they move through. TLC has three phases column chromatography has three phases similar to TLC, with that being the stationary phase, the mobile phase, and then your sample loaded onto it. So to repeat, we'll be using column chromatography to separate the three components that are in our spearmint oil, and then we'll be using TLC to identify what those components are. Okay, so the first thing we're going to do is we're going to set up our chromatography column. And to do this, we're going to use a 6-inch pipette. And the first thing we are going to do is we're going to put a pea-sized, I'm not sure if you can see it in my hand, but I have a pea-sized amount of glass wool. And we're going to pack this into the bottom of our pasture pipette. So I'm just going to stick it in there, like so. I'm sure you can't really see this part. And then I'm going to pack down the piece of glass wool with this little glass stir rod. As such. And then next, we are going to add our silica gel to our chromatography column. And it's really important that we add the silica gel inside of the hood. Silica gel is very hazardous, can get stuck in your lungs, and not good. You die. As you're adding it, you want to make sure that you tap the sides, because you want it to be very uniformly packed. If there's any breaks or fractioning of the column or the silica gel in your column, you won't get as good a separation. Okay, hi everyone. So our first step is going to be, we have 8 small test tubes here, and we're going to fill one of the test tubes with 2 milliliters of hexanes. Now we'll be collecting 2 milliliter fractions during this column, and so when we put 2 milliliters of hexane in, we will know how much volume 2 milliliters looks like, so that way we know how much to collect. So now that I put 2 milliliters of hexane in this test tube, I'm just going to mark the volume line. And so that indicates where my 2 milliliters is. And so that way when we're collecting our fractions, we know when to stop and move on to the next test tube. So after that, I'm going to pour an additional 2 milliliters of hexanes into this test tube, and that'll just fill it practically all the way. And these first 4 milliliters of hexanes, they're going to be used as solvent in our column to wet the silica gel. So I'm just going to pour those into a 50 milliliter Erlenmeyer flask. Okay, so here we have our chromatography column that we previously set up, and it is clamped to a ring stand with a 2-prong clamp and a piece of Tygon tubing, so that way it's not directly on the pasture pipette. So what we're going to do first is we're going to use our 4 milliliters of hexane solvent from the first step, and this is going to be used to wet the the chromatography column, the silica gel. So we're just going to use a pipette and slowly add
or the 4 milliliters of hexanes to the pipette that is acting as our column. And so it is going to take a little while if you just manually let it go through the column, because it has to pass through all that silica gel. So we're going to do a technique called flash chromatography, and that is going to push the hexanes through the column faster, and we'll be doing that by using this bulb right here. This is from your medicine droppers in your drawer. So it's kind of going a little bit faster than I thought, so I'm just going to put a little bit more of hexanes on top. Okay, and so when you do flash chromatography, you're going to put your bulb on like you normally would, and then you're going to push it down, and this will push your hexanes through. But you do not want to release this pressure until the bulb is completely off of the column. If you release this pressure and let air into it, the pressure will build up inside your column and it'll cause fractions inside of it, and that'll prevent even separation. So you want to keep it squeezed down as you slowly remove it off like that. And we're going to keep doing that until our entire silica gel is evenly wetted and saturated with the hexanes. Okay, so again, squeezing it through. We want to make sure that we don't let our hexane solvent go below the silica gel line, because we don't want our silica gel to go dry. We want to make sure that that remains wet and consistent saturation throughout it. This is very important so that way we get good separation from our column, and any inconsistency in the column, whether through saturation or fractions or breaks in the silica gel, that'll all affect how well your components are separated. So again, putting it on just barely to form a seal, pushing it through, and as you can see, we're starting to collect it. So I'm just going to push a little bit more out. We're almost at the line. I'm not going to release the pressure and just pop it off. And that looks pretty good.
Okay, so we're going to go ahead and add our sample onto the column. So our sample is spearmint oil. We're going to drop a little bit of that into our pipette. We don't need a whole lot, because all we're going to do is place 2 drops directly onto the top of the silica. We want to avoid getting it on the sides of the pipe of your column pipette, so that it has better separation. So we want to place that on there. 1, 2. So now that we've placed our 2 drops of sample, we can let them soak into the top of the silica before moving on to the next step. I have here 4 milliliters of hexane. You would have prepared this in an earlier step. It's the first of your solvents. So what we want to do is go ahead and add this in, and this will start your chromatography now that your sample is loaded. So we're just going to add that in. If you wet the sides, it'll get any sample that you got on the edges. And then we can go ahead and begin the flash chromatography again, as we saw before. While you've added your solvent, you also need to switch out your flask for your set of samples instead. Now, one way to do this is just to hold it. If you're having an issue getting this adjusted, you can simply just hold this here. It won't take long once we start using flash chromatography. And this one is marked right above my finger where the 2 milliliter line is. So we're just going to place the little pipette bulb on the top and squeeze it, and if you can see, the solvent is now moving significantly faster. Once you get to a certain point, you want to pull off that bulb once again, making sure that you're not releasing until you finish removing it. Add some more solvent so that you don't let your column go dry. And then continue with your flash column procedure. It's significantly faster than using a gravity column. Approaching that 2 milliliter mark we made earlier. So I'm going to stop the flash, place it over there, and swoop my new one underneath. Now this is the last of our solvent. Alright. Now that you've finished the last of your solvent, you finished running the column.
Okay, next we're going to be taking TLCs of each of our fractions, but first we're going to be taking TLCs of the three components of spearmint oil, and those are R- carbone, 1R, 2R, 4R dihydroxycarbone, and plus limonene. And then we'll also be taking a TLC of just an unknown spearmint oil. So first thing we're going to do, just like last week's lab, is we have our TLC developing chamber, and inside we put a piece of filter paper that acts as a wick. And then we're just going to check and make sure that our TLC silica gel plate fits into the jar properly. So we're going to place that in, and spoiler alert, it does fit because I've already cut off the part that doesn't fit. So if your TLC plate bends, then you'll have to cut off to make sure that it can properly fit inside. So next, I'm going to take my 10 milliliters of 10% ethyl acetate in hexane solution, and this will be what we're using to develop our TLCs, and just pour that into the chamber. And then I will put the cap on so that way our solvent does not evaporate. And set that to the side. Next, we're going to set up our TLC plate just as we did last week. And you want to remember that when you're setting it up, you're first going to draw a baseline at the bottom. And this is where you will do your spotting of the plates, or of each component. Like so. And make sure you want to be doing this in pencil because pen will run and pencil will not. And then I'm going to be doing 4 TLCs per plate. So I'm just going to make 4 evenly divided hash marks. And each of them will be a different component. And then, so here we have our, there we go, as you can see. Cool. Alright, so then I'm going to take my capillary tubes, and remember you don't want to open that up, just because these are more expensive than you would think. And if you spill them everywhere, they're very easily broken, and it's a mess. So, I'm going to start spotting the 3 components, and to do that, you just take your capillary, and you stick it into the solution. Some of it goes into the capillary tube, and you push down like so, and you get a small spot, or spot them all. And then we would fast forward this part. Definitely fast forwarding this part.
Gentle, gentle.
You're right, I'm freaking out.
Haste makes waste.
You're right, you're right, you're right. Okay, welcome back guys. Our TLC plate has fully been developed, so we're just going to take that out using our forceps. Reclose our TLC chamber so we can keep using it. And then we're just going to mark the solvent line wherever that ended up. Okay, now we're just going to set this forward to the side for now. Should have used forceps when I picked that up. My apologies. Okay, so now we're going to develop or make another TLC plate, and this one we're going to do our 3 components again. I'm not going to read them out again, but our 3 components. But instead of doing an unknown of spearmint oil, we're going to do an authentic spearmint oil, and that'll be our only difference in the spotting. So okay, and so now we're going to put our spotted TLC plate into our TLC developing chamber, just like we did before. And we're going to cap it just as we did before. There we have it, and we'll just let that develop, and we'll catch you on the flip side.
Okay, so to start off with TLCing your fractions, you need to first make a spot plate. So this is a spot plate here. It's just a grid across. You just need 8 spots because you have 8 fractions. and you put a number in each box. And all I'm going to do is take a new TLC spotter for each sample, and I'm going to put a spot inside that box. It can be a big spot in this case because we're not worried about putting too much sample on for a grid. So then I'm just going to go ahead and do this for the rest of these spots, 2 through 8. Okay, so it's hard to see right now, but we have our spot plate here, and we're going to use UV light. It talks about it in your manual, why you need to use UV light. But if you can see now, it's lighting up with a bright green, and there are 2 dark spots in 5 and 6. So we're going to go ahead and circle those, but this is all you need to do when you're looking under UV light at a TLC plate, is to look for anything that's lighting up. And in fact, there is a little tiny spot that's very faint on 8 that I might circle as well, but 5 and 6 are our nice strong spots. Good. Okay, so I've already placed a origin line and placed spots for my fractions to go, and I'm just going to go ahead and place a spot for each of these onto the origin so we can run a full TLC. So there's a little bit that you draw up in there. Sometimes you gotta double check, make sure you actually got some. And you remember, you just want a small dot, like 1 to 2 millimeters, because in this case it does matter how much sample you load. And you still don't want to contaminate, so make sure you're using a new TLC or new TLC capillary for each sample. So I'll go ahead and continue spotting these. I still have to do 3 through 8, and you'll join us when we're getting ready to put them into the developing chamber. So at this point, I've finished spotting the TLC plates for the fractions, so we're going to go ahead and place these in here. And for efficiency's sake, I set up 2 developing chambers for this so that we can develop both of them at the same time. Alright, so once these finish developing, we're going to go back over and show you the UV light again, and then we're going to move on to staining all of the plates that we've done so far. Okay, so now we're going to go ahead, and all of the TLC plates are here, so these first 2 are the fractions, and then the other ones are the ones that the other instructor showed spotting of. It is the actual samples as well as your unknown sample that could be adulterated, and a known sample that you were using. So you can see here what we expected to see, which is that on our grid plate we had the 5 and 6, which are right here. They showed up under UV light, which meant that they had conjugated double bonds. And as we expected, when we did full TLCs, 5 and 6 were showing up with UV spots. So I'm going to go ahead and circle those real quick. And you want to be as gentle as you can. These plates have been developed, so sometimes the silica is a little bit more fragile. Then I'm going to move over here onto these. So these ones have UV spots above the first compound and above the unknown sample, which could be adulterated. But it is showing up under the same RF essentially as the unknown over here, or the sample over there. And we're seeing again that R, as expected, should be spotting again. And there is actually what appears to be coming up from the known or the L, so we'll just circle that one there. Looks like the plate might have leaned a little bit when it was developing, so it does have a little bit of a lean to it. We'll have to see which one that was for. But the other samples and the other fractions didn't show any UV light.
Okay, hi everybody, and now we're going to move on to staining and developing our TLC plates on the hot plate, just like that we did in the last week's lab. So our stain this week is going to be potassium permanganate. It's very pretty pink. I'm a fan. So I'm going to start by doing the plates of the components, not our fractions, the known components. So I'm just going to dip the plate into the stain. You want to make sure that you get it completely stained up to the solvent line that you drew. And then I'm just going to dab the excess off on the side, like so. And this already clearly has the 4 spots on it. I'm still going to put it on the hot plate, but we'll show you a more close-up one after we're done with all of them. And so now I'm going to do the components with the unknown. This is the components with the known spearmint oil. So this one could potentially be adulterated. We'll find out. So again, just dipping it in, trying to drip off some of the excess stain. Then you're just going to pull out the edges, like so. And then again, you can clearly see the spots. I'm still going to put it on the, I'm going to blot a little bit more first, and then put it on the hot plate to develop. Okay, and so here are the TLC plates that were stained and developed. And you'll be able to match each of the components with the components that are in the known or the unknown. Okay, now we're going to do the exact same thing for our TLC plates that have our fractions spotted on them. So we're going to dip those in, and just like before, blot the edges to get the excess off. And place it on the hot plate. And place it on the hot plate. Okay, so here are all 4 of our TLC plates together, just so you can see them all.